So let's think about the other class-specific methods that we might write when designing a class. So again, these first four components will go into every class that you write. Now, obviously, they'll be different. You'll have different variables and different checks inside your setters, and your toString output will be different. But these four building blocks will go into all of your classes. But then you need to think about what is the functionality that you want these objects to be able to take. So what actions should the objects be able to take, or what actions can be performed on those objects? So to do that, we write methods, and those methods represent the functionality for the class. They represent the behaviors of your object. A lot of times methods will change an object. They'll often do this by updating the instance data variables. And again, they can access those instance data variables because they're all in the same class. Sometimes a method can send back information through a return value. Sometimes a method could be void. Okay. You can also think about having public and private methods. So your public methods are those that are accessible to someone who creates an object of this type. Again, those form the functionality of that object. But you can also include private methods. And there's two kind of main situations that you might want to include a private method. One is if you find yourself writing a public method that gets really complex. So if you find yourself writing a public method that spans, two or three screens of code, you probably want to break that up. And when you break it up into kind of sub methods, smaller helper methods, you probably don't want those to be public because they're not meant to describe functionality of your object. They're just there to help implement another method. So it's usually a good idea to make those sort of helper methods private. Another good time to make private helper methods is if you find yourself repeating code in more than one place. So if you're typing code and you realize, hey, I already typed this somewhere, and you see that that code exists in another method, it's a good idea to strip that code out of both places, encapsulate it in a private method, and just invoke that method from both places. In general, cardinal rule of thumb for any programming languages is reduce duplicated and repeated code. You don't want to have the same code existing in more than one place. It's best to put it in one place and then use it. And in Java, we do that by putting it in a method. So when we're writing our class-specific methods, we first have to think about what they should be. So what kind of functionality do we want our object to have? And then once we think about that, we need to think about what the method should look like to represent that functionality. And of course, to do that, we think about the method header. So remember that the method headers have these components: visibility, so public or private, basically who should be able to access this. If it's public, that means we're saying this is describing the functionality of an object. If it's private, it's just an internal helper method. Return type, so what kind of information is being sent out of my method. The method name, and we're going to want to follow naming conventions. The formal parameters, so what kind of input needs to come in to the method. And importantly, remember that we have all the instance data inside the method. All of our instance data variables exist in the class, and so I can access them in the method. So I never need to take instance data variable information in as a parameter. I wouldn't do that because I have that information already in the class. The last thing that I want to note is that your class-specific methods will not be static. I'm not going to talk about why because we aren't going to talk about static just quite yet. Eventually we will, but for now, just note that you do not want to make them static. So let's think about some class-specific methods for die. So one jumps to mind, obviously, and that is roll, right? We've got this die. We want to be able to roll the die, right? To have it have a new randomly selected number on its face. So let's think about the method header. So we definitely want this method to be public, right? We want people to be able to roll their die objects. So we need to think about the return type. Now, I think different people could choose different return types here. So you could think about returning an int, so returning the new value that's rolled. You could think about making the return type void, of saying, I just roll the die and update face value, but I don't give you any information back. You have to then access the face value through the getter. You could return a Boolean saying whether the roll was successful or not. Right, so different methods, different return types that you could send back. I think the two that make the most sense are probably int or void, and we're going to make it int just for practice. But again, you could make this void, and I think that would also be a logical thing to do. So I'm going to say that we'll return an int, and I'm just going to call my method roll. And do I need any parameters? So do I need any inputs coming from outside? I don't, right? Because all I need to roll is I need some way of generating random number, which we'll look at, and then I just need to update the face value. So I don't need any outside information for that. So my parameter list is empty. So in order to roll, I need to generate a random number between 1 and 6 inclusive. Now, we're not going to talk about random number generation in this particular video. That'll be a focus of another series. So I'm just going to show you what the code looks like and just briefly talk about it, but we'll go into more depth about random numbers at another time. So to generate a random number, we're going to create an object of type random. Random is a class in the Java Standard Library. So I'm now acting as a client of the random class. I'm going to create an object of type random, and I'm going to call it generator for my number generator, and I just create that as a new random object. So this is a call to the random constructor. It doesn't require any parameters, and this sets up a new object of type random. Now, I do need an import statement because random is in the java.util package. So I need to import java.util.random or .star in order to be able to access random. Okay, so that's my random number generator. Now, in order to generate a number between 1 and 6 inclusive, I can say, call it random value. I use the code generator.nextInt. So the method is called nextInt. I'm invoking that on my generator object, and I pass in the size of my range. So for us, the size of our range is 6. That's how many possible options there are. And I want my numbers to begin at 1. So this is what the code looks like. The number passed in as a parameter is basically the number of choices that you're picking randomly from. And then the number added on outside is how much you're shifting up from 0. So if I just invoked this here, that would return to me random numbers 0, 1, 2, 3, 4, 5. But of course, I don't want a 0 to be on my die. I want them to go 1 through 6. So I just shift everything up by 1. Again, I'm not going to talk any more about this now. We will talk about this at another time. Note also that there are other ways to generate a random number. This isn't the only way, but this is the way that we'll use for now. Okay, so that's going to be my random value, and then I can just assign face value to that random value, right? I actually wouldn't even need this local variable. I can just assign it directly. Okay. And then I can return that new face value. Okay, so there is my roll method. Now, in looking at this, I'm seeing some hard-coded numbers, and I might want to think, okay, is this a good place to use constants? And again, I think it is. So I'm going to go up here, and I'm going to create some constants. So I actually already have one for minimum face value, so that's good. And I have one for maximum face value too. So actually, I can use these constants that I have already. So what I can say is my range is going to be the maximum that I can possibly get, that's 6, minus the minimum that I can possibly get, which is 1, and then I add on 1 to make it inclusive. So this is going to still give me the number 6, and then I'm going to add to that the minimum, which is 1. So this is the same statement, but I'm just reusing my constants to make it more explicit of what those numbers represent. And also, let's say all of a sudden I decided, you know what, I don't want these to be 6-sided dies. I want them to be 12-sided dies. Well, I could just come up here and change that to a 12, and I don't have to change anything else anywhere in my program. I only have to make that one change, and everything else will still work the same. So that is one of the main benefits of using constants, is it allows you to update your code in ways like that and make it very flexible and easy to update, easy to maintain. For now, we'll keep it a 6-sided die. Okay, so there is my roll method. So now I can go back over to my die tester, and I can say, okay, die1.roll. Now, roll is a method that returns an integer. Remember, when a method returns an integer, I can do anything with that method invocation that I would do with an integer. So I can print it, I can store it in an integer variable, I can also ignore it. So right now, if I want to roll the die, but I don't really care at the moment what the result is, I can just roll it and ignore it. So this is a case where it might make sense to just roll a die, and maybe I don't need the face value until later on in my program. Okay, so I could just roll it and ignore it for now. So I'm going to just comment out some of the earlier printouts that we have, so we can just focus now on roll for a minute. And I'm going to create a new die so we can start from scratch. So I'll create die 4 gets a new die, and I will print out that die so we can see what its value is, and then I'm going to roll it. And then I will print it out again. And we can see what its value is after the roll. Okay, so we can say, okay, the die is 1, we roll it, and the die is 5. Now again, I could have also just put the roll right inside of here. And that will now print out, whoops, extra semicolon. That will print out the new face value, which is in this case 6. It's randomly different from the last time, right? But it doesn't print out the toString, right? Because die4.roll returns an int. So it's just printing out that int. Okay, so I could do that if I just wanted the new face value. I could print the whole thing if I want to print out the die. I can also say, most recent roll gets die4.roll, and then I can print out die4 and print out the most recent roll, right? So I can store die.roll in an int variable because die4.roll returns an int. That's its type. Okay, so here we start with a 1, we roll and get a 2, we roll and get a 1, and we see that the most recent roll was 1. Okay, I could roll my die a certain number of times, so I could say int I equals 0, I is less than 10. Let's roll my die 10 times, and each time I invoke die4.roll. So roll it 10 times. Okay, that'll do that. And then I can get the most recent value, or the current value, I should say, of my die. Print it out. Or if after all those rolls, I want to obtain what the current value is, I can store it in a local variable, current value, and to get that, I can say die4.getFaceValue. So that'll tell me what my current value is. And that should, of course, match my toString because that's the current value of face value. So after rolling 10 times, current value is 4. And so, of course, toString prints out die value is 4. Okay, so that is my testing out of the roll method, right? So I can invoke it, ignore the return. I can store it in an integer. I can put it in a print line. I can do any of those things. Okay. Now, let's add some more functionality to our die class. So perhaps instead of just keeping track of the face value, perhaps we also want to keep track of the number of times that the die was rolled. And maybe we also want to have a method that supports, rolling the die a bunch of times and counting how many of a certain number appeared in that set of rolls. Okay, so let's think about adding some more of functionality. Before we do that, I want to go back and first revisit our constructors. So right now we had an initial face value where we could create a die. The user could specify creating a die. And then we also had, if the user did not specify, we just set it to a default value. Now, this might not make sense to always start a die to the initial value. Perhaps we say, well, actually, instead of setting to a default value, I actually just want to roll the die and set it to a random value, right? I don't always want my die showing up to 1. If the user doesn't tell me what side to start on, I just want to roll it and start on that side. So we can do that. So I can invoke the roll method from my die constructor. Okay, and so what happens now is when a user creates a die using the default no argument constructor, we will randomly generate the number that shows on top. So if I create a die, again with no parameters, and print it out, so this time it was a 2, this time it's a 6, this time it's a 3, and so on. Okay, so that probably makes more sense in terms of what the real functionality of a die might be. And we notice that I invoked the roll method rather than generated the random number myself because, again, I want to reduce duplicated code. So instead of writing this random number generation code again, I just said, well, hey, I already have that. It exists in the roll method. I'm just going to invoke that roll method. And here's a case where I'm ignoring the return value. So roll does return an int, but I don't need to use it because the roll method also already updated my face value variable. So I don't need to do anything with that returned integer in the constructor. I can just ignore it. I also now no longer need my default face value, so I can get rid of that. I'll leave it commented in case you're running older versions while you're going through and looking at this. Okay, so let's now add another instance data variable to keep track of how many times our die has been rolled. Okay, so I'm going to keep track of that as a private instance data variable, and it's going to be an integer, and maybe I'll call it number of rolls. Okay, so this is now another instance data variable. So now I need to update this inside of my constructors. So remember that the constructor's job is to set up the object, and to do that, it initializes the instance data variables. So now I have a new instance data variable, so I need to initialize that in my constructors. Does it make sense to initialize this through a parameter? Probably not, right? Probably if we're creating a new die, we want it never to have been rolled before. Okay, so what I can say is if you tell me the initial face value, then I'm going to set number of rolls to 0. It hasn't been rolled at all. You just gave me a die and put it facing up on a 3. Hasn't been rolled yet. Okay. If I'm going to create a die without any parameters and call the roll method, well, now I want to indicate that it's been rolled once. So what I can do is I can still initialize number of rolls to 0, but then down in my roll method, I can say, well, every time someone invokes this method, let's take that number of rolls and let's increment it and say, yep, you rolled one more time, rolled one more time. Okay, so in this way, we can keep track of how many rolls there are. Now, because I have a new instance data variable, I might decide to include that in my toString. So now I can say die value, and perhaps then I add on, rolled times, something like that. I also will want to add in getters and setters for that value. So anytime I have an instance data variable, I need to think about getters and setters. So for a getter, it's going to be pretty straightforward. I'm just going to say public int get number rolls, no parameters, and I'm just going to return number rolls. Now, for a setter, this is a type of variable where I don't think I want to include a setter. I don't think a client should be able to come in here and directly set how many times this die has been rolled. The only way that that variable should change is if someone invokes the roll method, and then I change it based on, I increment it by 1. But I don't want someone to create a die, roll it 3 times, and then use a setter to come in and change the number of times rolled to 10. Like, that wouldn't be a logically consistent object. So for some instance data variables, you can make the choice to omit a setter and to say, nope, I'm not going to let an outside class change this variable. You still might include a getter like I did here. Like, I want to let an outside class know what this number is, but I'm not going to let them change it. So I'm going to omit a setter. So I'm not including a setter. That method, that value is only going to be changed by the roll method. Okay. Okay, so let's now go over here to our die. And we can see here for our die here, after we had that loop of 10 times, that die has now been rolled 13 times. Okay, so we're now keeping track of that. We could also say, int times rolled equals die 5 dot get number of rolls. So that's an integer method, so I can invoke it and use that returned integer to store into a variable, to print it out, to do anything I can do with an integer. Okay. One more method that we'll write is, let's think about, you want someone to say, okay, if you roll the dice 10 times, how many 6s did you get? If you roll the dice 100 times, how many 3s did you get? Okay, so that's the functionality I want to add. So I actually encourage you to pause the video and see if you can write that method first on your own, and then come back and play the video and see how yours compares to mine. Okay, so hopefully you did that. So this is going to be, again, a method to roll the dice a certain number of times and then figure out how many of a certain number was generated in that set of rolls. So it's going to be a public method because this is functionality we want a user to be able to use. I'm going to return an int, right? Because I'm going to return a count. And I'm going to call my method, count values, perhaps, okay? Following our naming conventions. Now, I do need input into this method. I need to know, first of all, how many times someone wants me to roll the die, and I need to know what number I'm looking for. Okay, so I need to know, I'll call it the target value and the times to roll. So those are my incoming information. So how can I calculate this value? Well, it always helps to start with pseudocode, kind of thinking about the steps you're going to take before you start writing. So I might say, well, I need to roll a certain number of times and count up the matches. Okay. So rolling a certain number of times, that sounds like a loop. I know in advance how many times I'm going to loop, so for loop is a good idea for that one. So I'm going to use a for loop for an I equals 0. I is less than the number of times to roll, I plus plus. And what am I doing that many times? Well, I'm just rolling, right? I'm just rolling the die. So that takes care of the rolling a certain number of times. Now I need to count up the matches. So I need some way to keep track of my matches. So I'm going to declare a local variable called matches and initialize it to 0. So when I start this method, I don't have any matches. Okay. I roll a bunch of times. Now, each time I roll, remember that the roll method returns an integer. So I can say, all right, well, I can say the current roll is the roll, the value returned from roll. And then I can use a conditional to say, okay, if the current roll equals my target value, let's increment the number of matches. And then when this is all over, I can just return matches. So let's go back to our tester program here and let's create another die. Let's print it out. And then let's ask how many times. Let's say count values. Maybe I should call it count matches. That might be a better name. Let's see how many 6s we get if we roll the die 60 times. Okay. And at the end, we will also print out our die. So we roll this. So we got 11 matches and our die was rolled 61 times. Where'd the 61 come from? Well, remember that it was rolled one time in the constructor. So that was its first roll. The very first time I created the die, I rolled it. And then I rolled it 60 times as part of the count values. Now, had I created this with a number instead, it would only have been rolled 60 times because that's how we defined our constructors. Okay. So let's say, we'll try it again. So that time we got 11 matches, 12 matches, 9 matches, 8 matches, 5 matches, 6 matches, 10, and so on. Okay? So let's go back. Actually, I am going to change the name of this method, and I actually did want to show you a way that you can do that in Eclipse. You can do this in most IDEs, but it'll be a little bit different depending on the IDE you're working in. But in Eclipse, if you decide you want to change a method name or a variable name, of course, you can manually do it and copy and paste all over the place, but a better way to do it is let Eclipse do the work for you. So what I can do is I can highlight the name of my method, right-click, go to Refactor, Rename, and now I can just type in the new name. So I'm going to say, okay, instead of count values, I'm going to make it count matches, and then click Enter. And the nice thing is that not only did it change it here, but over my tester program, it automatically changed it there. So it changes that variable or method name everywhere it appears. It does that for you. So that's a nice little trick to know if you kind of change your mind about a variable name or a method name. All right, so there are some of our, class-specific methods that we have used. And the ideas to think about here are your method headers, how to best represent your functionality. Think about reusing code. So here we've reused the roll method multiple places, right? We've invoked it rather than continually repeating the code of finding a random number. I just let roll do that work one time and call it. And we also talked about the possibility of not including setters for some of our instance data variables. So that is a summary of writing our own classes. We are going to do lots more examples, but just as a quick review, a class is a blueprint of what an object will look like. It talks about the characteristics of that object and the functionality of that object. Once you create your class, you've created a new data type, and you can then create objects that have that data type. The basic building blocks of all of our classes are the private instance data variables. Those are your characteristics of your objects. Constructors, that's the method responsible for setting up your object. Public getters and setters, that allows access to private instance data variables. Now, those setters might contain restrictions that allow values only to be set to certain things. That will most often happen with a numeric variable, but not always. It sometimes can happen with string variables or things like that. You also might choose not to include a setter for some variables. A toString method, that is your way to create a text representation of your object for easy use in printing. And then after that, once you've got that core part of your class up and running, then you can add on the class-specific methods. So if those methods are public, that means you are creating functionality of your object that a client can use. And in doing so, you might also choose to make private methods. You might do that to help you implement a public method that's become too complex, or to reduce duplicated or repeated code.